This lesson is all about the volume of pyramids and cones. A pyramid has one polygon base. So what's a polygon? Well, it's basically a shape with any number of sides. It could be a square, it could be a triangle, pentagon, hexagon, anything. The sides are triangles and they meet at a point. Here's some examples. You can have a square-based pyramid, a triangular-based pyramid. This is a pentagonal-based pyramid. All of them have a polygon as a base, and the sides meet at a point. And all the sides are triangles. So that's the definition of a pyramid. Now, the warm-up demonstration that I showed from that YouTube video showed us that the volume of a prism is 3 times the volume of the pyramid with the same height and base. In the video, you saw a cube getting filled by the volumes of 3 square-based pyramids. And so we can say that the volume of a pyramid is the same as the volume of the prism with the same base divided by 3. So for example, this pyramid has a square base. So the volume of this pyramid is the same as the volume of a prism with this 12 by 12 square base, which we know is base squared times height, but then divide it by 3. And this is where the formula for volume of a square-based pyramid comes from on your formula sheet. Volume is b squared h divided by 3. So now we can just plug in our numbers and solve. So we end up with a volume of 480 centimeters cubed. Now over here, this isn't a pyramid, but it's a cone. Now a cone is very much like a pyramid because it has a base and the sides meet in a point. The only difference is the base is just a circle. It's not a several-sided polygon. But the principle is the same. The volume of a cone is the volume of a prism with the same base. So in this case, the volume of a cylinder, pi r squared h, and then divide it by 3. So this is where the volume of a cone formula comes from on your formula sheet, pi r squared h divided by 3. And so we can just plug in our numbers and solve. We get the volume of 31.4 centimeters cubed. So just watch out anytime you're given the diameter of the circle. If it asks for radius, you have to make sure you're not putting in the diameter. You have to take half the diameter to make the radius. So in this case, the radius was 2.2. That's where I got this from. Now for this next example, I'm kind of switching gears. I'm not really talking about a pyramid at all here. This is a triangular prism, and I'm asked to calculate the volume. And you might be thinking, well, that's what we did last lesson. The reason I'm putting this in is because this is actually a trickier question because you don't have the height of this triangle. You need to figure that out in order to find the volume. I just wanted to throw in this tricky question. Pause the video and see if you can figure out what to do, and then check back in to see how you did. I know that the volume formula for a triangular prism is BLH over 2, where B is the base of the triangle face, L is the height of the triangular base, and H is the height of the prism. But I don't know what L is. In my diagram, it's not given. So this is where I used my mind and figured out, well, this right here is a right triangle. And because this is an equilateral triangle and the angles on both sides are the same, that means that this side length is cut in half, which means that's 10. So I've just redrawn that triangle here, 10 centimeters, 20 centimeters, and L. It's a right triangle, which means I can use Pythagorean theorem, which I've done here. Don't forget to put the hypotenuse in the correct spot when you're using Pythagorean theorem. Otherwise, it won't work out properly. So here's my work. I get 17.3 centimeters approximately for this value of L. So now that I have that, I can use it in my volume calculation, and I can get the volume of this triangular prism, 5,190 centimeters cubed approximately. So now in this example, when I'm asked to calculate the volume of this square-based pyramid, I can use a similar method to what I did in the previous example, because this does not give me the height of the pyramid. This 7 centimeters, that's called the slant height. And I can't use that as the height of the pyramid. The height of the pyramid is actually from the center of the base perpendicular up to the top point. So I need that value in order to figure out the volume of the pyramid. So see if you can use a similar method to the previous example to solve this problem. Pause the video, try it, and then check back in to see how you did. I used the right triangle here to find h. Because this goes halfway across the square base, I know that the distance is 4 centimeters. The slant height of the pyramid is 7 centimeters, so that's the hypotenuse of this triangle. I used Pythagorean theorem to find the height, and I used that value in my volume formula for the volume of a square-based pyramid, did my calculation, and I got 121.6 centimeters cubed. For this last example, calculate the volume of this cone. Try it on your own. I used the same method to find the height of the cone. Pythagorean theorem, it was about 9.2 centimeters. So I plugged that into my volume formula for a cone. I did the calculation and found that the volume was about 346.8 centimeters cubed. So that wraps this lesson up. If you have any questions, let me know. Otherwise, you can move on to the practice questions.